Welcome to Module 9, our Module 9 presentation of the 279W Windows Server Administration class. I'm your instructor, Robert McMillen. This is the final module in our class. So Module 9 is going to be all about troubleshooting, operating system troubleshooting tools, problem-solving strategies, troubleshooting processes, boot problems, and solutions. And your lab will be reflected in all these different tools that we learned about in previous modules and how to use them to help you troubleshoot issues. We're going to talk about TCP/IP and different types of addressing, name resolution, and the tools we'll review one more time for this particular lab. So, problem-solving strategies. When you go to troubleshoot a problem, you have to think about what are you going to look at first? What are you going to do to protect things before you start diving in to see what the problems are? So you need to be aware of the network layout. Train users to help, actually. Tell them to save their work, record error messages, notify appropriate people and personnel, and by having the users trained, they will help you save a lot of time and save a lot of problems. Having a methodical approach, of course, is a good thing. Decide what your approach is going to be. Not everyone uses the same approach, but a methodical approach has you go through step by step. What's the most important thing first in your office? Is it email? Is it internet access? Is it video access? Is it video cameras, security cameras? What is the most important thing? And you methodically go through all those different, from highest importance to lowest importance, until you get to where it is that you need to fix the problem. And you also need to track and log the problems as well. Determine the problem, ask questions, determine the scope of the problem. Try to recreate the problem if necessary. You may want to have a sandbox lab where you can recreate problems by having software installed on a test server. Gather details about what has changed. Was there an update done? Was there a power outage? What other changes might have happened? Devise a plan to solve the problem. Have a rollback strategy. If the problem resolution you come up with actually makes things worse, you need to be able to roll that back. Implement the plan and observe the results. So you've got to observe those particular results and, of course, document those changes and results for the next time you have a problem. So some of the more common things that come up is a driver video issue, and you may need to boot into safe mode. Well, that'll be one of the things you do during your lab, is booting into safe mode. You could also have a severe system problem. You may need to understand command line because some of the graphical user interface programs don't work anymore. Windows Complete Restore. You can also use the Windows Server backup that you were shown in previous labs to know how to restore from a backup drive or tape. Memory issue, memory diagnostics tool. You need to boot off of an operating system DVD. So one of the biggest things that could happen is you could have an issue with TCP/IP. So it's important to understand what TCP/IP is. It is a networking protocol installed by default, and it's what you use to communicate between servers and other computers. And that IP address can be static or dynamically addressed. TCP over IP is really what we're talking about here. TCP is the connection-oriented protocol for reliable end-to-end communication. What that means is when the server or any computer sends data from one computer to another, if it's using TCP/IP, which it is in this particular case, it's going to make sure that that data got there, and it got there in the correct order. If it detects that there's any kind of a problem, it will resend it. So that's what makes it a reliable protocol. IP is the card that TCP drives in. So IP routes the packets of data using an IP header with information and an IP payload, which is the data that you're trying to send. You can manually address IP addresses like you did with DC01 and with your clients. That's manual TCP/IP or static addressing. Static addresses are fixed. They don't change unless you change them. You usually assign static addresses for servers, things you don't want to change the IP addresses on a regular basis like you would for workstations. You need to configure additional information to help the server navigate the network, such as the subnet mask and gateway, etc. On the other side of this is dynamic addressing. So if you don't set a static address on your network card, that means you likely have a DHCP server somewhere on your network, and it's going to dynamically assign an IP address, the subnet mask, the gateway, the DNS information. And that is the default configuration. So if you want static, you have to go in and manually change it like you did earlier. Two different types of addressing, both the 32-bit and the 128-bit IP version 6. So you went ahead and set those IP addresses and their subnet masks and the DNS information for both of those. Now, with IP version 4, there's only 4 billion addresses approximately, but with IP version 6, there's 100 million quadrillion. So if we wrote out all the zeros here, you would not have enough zeros on this page or many other pages and to get to the end. Both are enabled by default. This is an example of a full 128-bit IP version 6 address. All addresses, whether version 4 or version 6, have a network ID and a host ID. So in order to communicate with between client 1, client 2, and DCO1, they all start with 192.168.10. That is the network ID. The host ID is the final IP address, which was .1 for DCO1, .2 for client 1, and .3 for client 2. So those, as the host, they cannot be the same. The first three have to be the same. The last one has to be different. Sort of like if you are all on Main Street, you can only have a house number 1, house number 2, and house number 3. They can't all be house number 1. So the street is like the network ID, where they all have to be on Main Street, and they all have to be 192.168.10. The host is like the house number, house 1, 2, and 3. Now you can slide that back and forth using the subnet mask. So if you decide to do 255.255.0.0 instead of the default that we used, then you'll have more host IDs, but you'll have less network IDs. Hosts shouldn't be connected directly to the internet. They should connect indirectly using network address translation. A device, such as a router or gateway, is responsible for translating the public to private addresses. So you're going to need a router. Routers are needed for hosts on a network to communicate with hosts on other networks. So basically what that means is you don't want everybody to know DCO1 is 192.168.10.1, so you have a router or a firewall which does network address translation, which hides the actual IP address of DCO1 and instead uses its outside IP address of the firewall or router. And that's the one it broadcasts to the world saying that that's where you're coming from, and that protects you against hackers. We have several different types of name resolution. When you go to connect to a computer or connect to a website, then you're going to want to use a name. You're not going to want to connect to it by IP address. So DNS is the default domain naming service that you'll use for resolving names to IP addresses. An older version is WINS, with the Windows Internet Naming Service. That one was typically used by Windows NT4 and Windows 2000. It does not use fully qualified domain names. So instead of www.microsoft.com, it would just use a single name and not a full name with a .com or .edu or a .local at the end. So because it's not very flexible and not extensible, we've moved away from WINS, although it still is available in 2008. LLMNR, Link Local Multicast Name Resolution, that's used typically in version 6, but can also be used in TCP/IP version 4, and that's for local multicast name resolution. That's a newer protocol. It's mostly used in workgroups. So some of the tools that we learned about earlier that I showed you how to run from a command prompt are going to come up again in this particular lab. So you'll need to just brush up once again on some of the commands such as ping, traceroute, path ping, netstat, nslookup. Some of the ones that we looked at previously, you're going to use these for this particular lab. So in conclusion, we talked about OS troubleshooting tools, TCP/IP, IP version 4 and 6, name resolution, and some of the different tools and commands. So let's take a quick look at our lab number 9. You're going to boot into safe mode. Of course, you press F8 to get into safe mode, just in case you forget. And you're going to be performing memory diagnostics. After it runs for a few minutes, you can cancel it. You're going to be using the event viewer. I showed you how to use the event viewer in previous modules, and you're going to actually use the event viewer to help you troubleshoot an issue. You're going to be using TCP/IP connectivity troubleshooting tools such as ping and traceroute, that kind of thing. And then you're also going to configure to enable remote access through remote desktop. So remote desktop comes in two different flavors. One is the administration mode, which is on the server by default. You just have to enable it. And the other is the application mode. The application mode is if you decide to have non-administrators connect to the server to run things like Office and other programs. So I'll show you very quickly on how to enable remote desktop. So if we go back to our computer, right-click, go to Properties, and then we click on Remote Settings in the upper left-hand corner, we can enable remote desktop simply by checking the Allow connections from computers running any version or allow specific programs. Allow specific versions of remote desktop programs. So this is the lower security, this is the higher security, and then from here we can also select users. By default, administrator will have the ability to use remote desktop, but if you want, you can add other specific named individuals or groups to that list, and they will be able to remote into the server, and they'll be able to log in and make changes as if they were sitting in front of the server itself. So that concludes our Module 9 and all of our modules for the 279W class. I've been your instructor, Robert McMillen, and good luck with your labs.